The weather plays an obvious role in baseball performance. When the weather is cold, we know that strikeouts go up. We also know when the weather is cold that pitchers walk batters more often, and that's probably mainly because it's much harder to grip the ball. Home runs are rarer in cold weather. We know that home run rates go up by about 4% if the temperature is 75 degrees or warmer. One often hears announcers say that the ball will not carry well if the air is humid. In fact, that's false, and the reason is that water molecules are lighter than oxygen and nitrogen molecules that are found in the air. So the atomic weight of an oxygen molecule is 8, and the atomic weight of a hydrogen molecule is 1. So a water molecule, H2O, has an atomic weight collectively of 10, whereas oxygen molecules in the air are found as O2, so that would be an atomic weight of 16, and nitrogen has an atomic weight of 14 per atom, and so nitrogen is also found as N2 in the atmosphere. So what you find is that when the air is humid and there are water molecules in the air, then in fact the air is less dense than it is when the air is dry. We know that on wonderful days like this that the bright sky benefits pitchers, that pitchers are able to fool the batters more effectively. On cloudy days, the batters have the advantage and the number of errors tend to be lower. The error rate is going to go up on sunny days and error rates go down on cloudy days. So this table shows the changes in distance that a 400-foot fly ball hit to center field at sea level would fly under the effect of various meteorological phenomena. And we'll look at a few of the items here. As you go up in altitude, then the air becomes less dense. And that means the air poses less frictional resistance to a batted ball, and the ball should travel further. So for every 1,000 feet of altitude you go up, you increase the distance that that 400-foot fly ball would travel by 7 feet. We commonly measure barometric pressure in inches of mercury. The typical barometric pressure is 30 inches of mercury. So if we get a 1-inch drop, then the air pressure is going to go down. Again, we're going to get less dense air. We would expect that fly ball to travel an additional 3 feet, given a 1-inch drop in the barometric pressure. A wind of 1 mile an hour in the direction of the batted ball will increase the distance traveled by 3 feet. Coors Field in Denver, at an altitude of about 5,000 feet, is often referred to as the launching pad. When it was first built, home run rates were very high compared to other ballparks there. In 1996, just 2 years after the park was built, a new record for home runs in a ballpark in a season was set. 271 home runs, shattered the old record of 248, which was set by the California Angels, shattering the old record set by the California Angels. In 1999, the all-time record for home runs occurred in Coors Field, and that was 303 home runs. So Major League Baseball wanted to do something about the problem, and what they decided to do was to take the balls and put them in a humidifying environment to make them a little bit heavier, a little bit less elastic. And if we look back at our chart here, we can see that a ball that is saturated with respect to humidity travels 30 feet less than it would without being, that a ball at 100% humidity will travel 30 feet less than a ball that's in equilibrium with the typical humidity of a particular ballpark. So it was this characteristic that was used to modify the baseballs at Coors Field so that not quite as many flew out of the ballpark. Now, Coors Field has just the perfect conditions for hitting home runs. The air is thin because it's at high altitude. The air is dry. And so what that means is that the ball is not going to have very much humidity in it, and so it's going to be very elastic. And the wind is often blowing out. So great conditions for hitting home runs there. So this is a diagram of the humidor at Coors Field, and essentially what they do is they maintain the balls here in a saturated environment, and so the balls come to equilibrium and absorb a lot of moisture. So if you were to take one of the balls here and drop it on a cement floor, it would bounce, but nowhere near as high as a ball that was stored in Denver outside this humidor. Again, because of the low humidity environment in Denver, that the balls are going to have relatively little moisture absorbed, and they're going to be highly elastic, making them travel very far when the ball is batted. So Coors Field is still the site where lots of home runs are hit, but we no longer have such a dramatic difference between Coors Field and other National League ballparks. Altitude also plays a role in the behavior of pitches. So because of the high altitude, curve balls don't curve as much. And that means, of course, that pitchers are more at the mercy of hitters, so it becomes very difficult to throw an effective curveball or an effective slider to try to get batters out. So many very good pitchers do relatively poorly when they pitch at Coors Field because it's very hard for them to use their breaking balls to get batters out.